Jesse, Jamie, Jeremy, Jesse, Jamie, Amy, Lori, and Crystal go to the movies. How many different ways can they be seated next to each other in the movie theater if there are no restrictions? I told you that Jeremy, Jesse, and Jamie, who are my brothers, are boys, and Amy, Lori, and Crystal are one's me and my two sister-in-laws. So, there are no restrictions. So if there are no restrictions, we would use 6 factorial, which is 720, which is also 6 times 5 times 4 times 3 times 2 times 1, which is also the same as 6p what? 6p6. 6, the first 6 represents the actual first number we start with. We have to go down by 1 each. And the next one represents the number of blanks, remember? So 6p6, same answer. The boys and girls must alternate. Does it say I have to start with a boy and end with a girl, or start with a girl and end with a boy, or anything like that? No, so there's going to be 2 cases when you have an even amount. So we can start with all the boys. So we could go 3, 2, 1 for boys, boys, boys. And then 3, 2, 1 for girls, girls, girls. Please make sure that you see that you actually have the multiplication dots, which that is the same as 3 factorial, 3 factorial. We agree? 3, 2, 1, 3, 2, 1. Or we could start with what instead? Girls, which is 3, 2, 1, 3, 2, 1. So plus 3 factorial, 3 factorial. What could we have done instead of doing 2 cases like that and writing them both out? Multiply by 2. We can go 3 factorial times 2, which is actually 72. Pathways problems. Remember I told you to treat them like the word dir? So down, 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 right, right, right. So this one here would be down, 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 down. Right, 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 right. So the first word would be how many letters? 10 factorial over 5 factorial, 5 factorial. Then do I multiply or add? Multiply. And remember I told you, throw a really large dot in the middle here to connect them to remind yourself to multiply. Correct? Then the second one I get D, 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 R, R, R. So I get 8 factorial for the 8 letters, no restrictions, over 5 factorial, 3 factorial because of the repetition. Did anyone get the answer? Yeah. Agree? Disagree? Agree? Okay. Totally had that. If we go back in the tapes, it was there the whole time. Just review that. All right. Let's try this one. D, D, D. A lot of R's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow. So I get 14 factorial over 3 factorial, 11 factorial. Quiet, please. Then we have the dot in between because they're connecting them, which reminds us to multiply. Yes. Then we have D, 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 bless you, R, R. So 5 factorial, bless you, over 3 factorial, 2 factorial, times D, D, R, 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 which is 8 factorial over 2 factorial, 6 factorial. What do we get? Bless you. Did anyone get the answer? Pardon? All right. So it's always total amount of letters on the top divided by the restrictions, right? Not the restrictions, technically, the repetitions. Okay? There's no restrictions on the top. All right. And I did a little bit of calculus in here, ignore that. Okay. Number 10 says, how many three-digit numbers less than 700? So in order to be less than 700, it has to start with a number lower than 7, correct? Can be created using 1, 3, 4, 5, 7, 8, and 0. The catch is it's a three-digit number. If it was a three-digit code, could it start with the number 0? A code. Codes can start with 0. Codes could be 0, 0, 0, 0. Your house is broke into, but it could be that. Yes? Okay. It's a three-digit number, though. So can it start with a 0? No. And it has to be less than 700, so it also can't be 7 or higher. Can't start with a 0, can't be 7 or higher. Repetition is allowed. So we have 1, 2, 3 digits. I know the first number can be 1, 3, 4, 5, which is how many numbers? 4. Now repetition is allowed, so do I have to box and hold? No. Then I have 1, 3, 4, 5, 7, 8, and 0, which is 7, and then 7 again, right? If it said even, what if it said three-digit numbers less than 700 that are even? Then the end, I could only end in 4 and 8 and 0, correct? So I would have 3 options. If it said odd, I could end in the other one. So you have to watch for those words. So, what's 4 times 7 times 7? Repetition is not allowed. So I still have to start off with always where I'm restricted. No matter what, always where I'm restricted. So it's the first digit that I'm restricted on. So I have 1, 3, 4, 5, which is 4 options. But now I actually have to box and hold a number, correct? Because I'm not allowed to repeat. So whenever I do words, I always box and hold letters because you're not allowed to repeat them. Unless like there's 2 P's, but then you would just have those as options, right? Okay, 1, 3, 4, 5. Then I have 3, 4, 5, 7, 8, 0, which is 6 options. Say I hold the 0 then. 3, 4, 5, 7, 8, which is 5 options. And what do we get for this? (11) says, give me every different way you can represent the situation. There are 32 students in Mrs. Lepp's math class. She is randomly choosing 6 of them to go to a trip to 7-Eleven. So those 6 that I'm choosing, are they any more special if they're 1, 2, 3, 4, 5, or 6? No. So what is this? Combination. Order doesn't matter. If the 6 that I'm choosing, nothing is more special if you picked 1, 2, 3, 4, 5, or 6. You get to go to 7-Eleven, or we do not. It's a combination. If I gave you jobs, like one person to pick up the trash when they got there, one person to pay for everyone's food, one person to do this, one person to do this, then would it be a P? If I gave all 6 people different jobs going to 7-Eleven? Yes. All right. So, how many different ways? We could go 32, C what? 6, which is also the same as 32 and 6 in brackets, remember? There's that bracket one with the C. I can write it that way. What's another way I could do it? 32C what? What's the common difference, or what's the difference between 32 and 6? 26. Because remember, with C's and only with C's, you can actually take the difference and it'll get you the same answer. Right? We did 10C4 and 10C6 in our notes, and it got us the same answer because of the formula. Or we could also write it as 3226. Because that's a C. Remember that? For 12, we have NCR and NPR. You've seen in this unit, compare the 2 formulas. So remember, NCR is the NPR formula with an extra factorial. So NPR is n factorial over n minus r factorial. That's it. So if my calculator wasn't working and I couldn't use the 6P4 formula, or 6P4 button, then I could use the formula, right? NCR is the NPR formula with an extra r factorial because it gets rid of all the cases that don't, like the arrangements that don't matter, right? You get rid of the repetitions. So n factorial over n minus r, same formula. with an extra r factorial. It gets rid of all those cases that don't matter because I'm not taking the 6 people going to 7-Eleven and lining them up and taking a picture of them or something like that. That would be a permutation, right? Combinations, I don't care what order I pick them in. If you picked first, second, third, fourth, fifth, or sixth, like the last example, you get to go to 7-Eleven or you don't. I'm not like lining you up and taking a picture, making an order matter. So if order doesn't matter, you do the r factorial on the bottom and it gets rid of all those extra cases where order would matter because it doesn't. Okay, number 13. 100 people enter their name into a draw to win 3 prizes. How many ways can the prizes be drawn if all 3 prizes are the, yep. If you actually had to compare them with writing, you would have to explain that NPR is the permutation formula. In the permutation formula, there's n factorial over n minus r, and NCR has the same thing. It's the combination formula. So compare is similarities and differences. So you'd say they're similar in the fact that they actually look the same. The differences are that the C factorial has to divide, the C formula, the combination formula, has to divide by r factorial to get rid of the cases that are different. You have to do that actual explanation. This question doesn't give you enough to be able to explain more than that, but normally if I give you a compare, you have to do 2 similarities and 2 differences. So I would say my differences would be that using those formulas, combinations order doesn't matter, and permutations order does matter. Combinations, this one has an r factorial, so I'm getting rid of order that doesn't matter. Permutations doesn't have that. And then you could say they both have n factorials on the top. They both have n minus r factorials on the bottom. Okay? But yes, you would need way more explanations than just these 2 formulas. Okay, all 3 prizes are the same. Does being picked first, second, or third change your outcome? No. So it's always that extra. So I know that this would be either 100 C3 or 100 P3. I know those are my options. We agree? It's this number that really matters if it's a P or a C. So that 3 at the back. That 3 at the back, I say, okay, does it matter? If the prizes are all the same, does it matter if I picked first, second, or third? Is it going to change my outcome? If the prizes are all the same, does it change my outcome? No. So which one would it be? The C, because order doesn't matter. Now, what if all 3 prizes are different? If they're different, does it matter if you picked first, second, or third? Yes. So then what would it be? P. And sometimes, guys, they don't work these out. That is the multiple choice answer. Sometimes the numbers are so big that you can't work them out. For example, 14 has massive numbers. If you type it in your calculator, like it's a ridiculous amount of numbers. Okay? So what they'll do is the multiple choice answer will actually be like 8,000 C2 or whatever. Like it will just be the answer. It won't be like typed into your calculator 1,000 or something. So let's look at this one. A powerhouse committee is being formed from a school division made up of 25 principals, 250 teachers, 8,000 students. That's on the side just to help me out. If I needed to actually explain those, I couldn't write P, T, and S, yes? If I actually needed to explain this more, I would have to thoroughly write the word principal, teacher, students. This is just off to the side, a caveat to help me. It's not actually part of my explanation. I'm not showing any work with it. That's just for me to pull some data out of the word problem. They're wanting to form a subcommittee to discuss issues throughout the school division. So we're trying to form a smaller committee, and now we have to find out, does this committee have jobs? Then it's permutation. Or if you just get to be on the committee and you're all the same, then it's a combination, right? So let's keep reading. They want a 12-person subcommittee. How many ways can this happen if there are no restrictions? They just want a 12-person subcommittee. So if I pick first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, does it change my outcome? No. So I know it's a C. There are no restrictions, so I'm choosing 12. These 12, the order in which I get picked, doesn't matter. If I picked first or 12th, I'm on the subcommittee. If I pick 13th, I'm not on the subcommittee. That's it. You're on or you're not. Okay? No restrictions is often done worse than if I give you restrictions, because you're like, I don't know what numbers to pick. No restrictions means it doesn't matter which one of these outcomes you are. So just add them up. So what would this be? 8,275. And that's my answer. And I can't type it in. It gets like it overloads my calculator. That would just be the answer. Make sense? So if it's a multiple choice, they might give the answer like that. If it's a numeric response, they might say in the form A, C, B, the value of A is, and you put in a numeric response. So the value of B is, and you put in a numeric response. Okay? B, they would have to watch themselves because you could give the answer 12, and you could give the answer 8,263, because that would also get you the same answer. All right. Next one, you're going to have to help me get the numbers because they're on the previous page and I can't see them. They want 2 principals, 3 teachers, 7 students. So what I always do, guys, is I always say, wait a second, is that 12? If it's not 12, I need to supplement. So 2, 3, and 7 is 12. Yes? So we're in a good boat here. We need 2 principals and or 3 teachers. And 3 teachers, because if it was or, I wouldn't have 12 people, correct? And 7 students. How can I guarantee getting principals? Choose from principals. How can I guarantee getting teachers? Choose from teachers. How can I guarantee getting students? Choose from students, right? So you guys have to help me. How many principals was there? Now, is it a C or a P? It's a C. Remember, if I choose principals from principals, students from students, teachers from teachers, drivers from drivers, irons from irons, middles from middles, defense, defense, forwards, forwards, boys, boys, girls, girls, clubs, clubs, spades, spades, diamonds, diamonds, red, red, black, black. Any of that, it's a C, right? When you're choosing from the group to get the same thing, it's always a C, because order doesn't matter, because I don't have jobs. So 25C2, and means multiply. How many teachers were there? 250? 250 C, 3, and means I multiply. Students? 8,000 C7. Done. The next one, there must be 7 students. A lot of people will give me the answer 8,000 C7 and call it a day. What's the problem with that? I need how many? 12. So I'm missing some people. Right? So I need 7 students, and then people are like, I know I need 5, but I don't know what those 5 need to be. You only have so many options, correct? What is the only thing they can't be? They can't be students, so they could be what? 5 technically principals or teachers, right? Or what could we write? 5 not students, technically. We could just say 5 not students. It has to be anything but students. Okay? So how many students are there? 8,000. Is it a C or is it a P? C, because it's students from students, right? They don't have any jobs. So it's 8C7. The first 7 students who get chosen get to be on the subcommittee. There's no more special if you're number 1 or you're number 7. You're all on the subcommittee, right? You might be like, ooh, I hope my name gets picked. Like you might be like, I'm a little anxious, but it doesn't make your outcome any different if you're 1st or 7th, right? Then I know I'm choosing 5. Most people are good at that. They just get stuck at this. What's this going to be? Principals and teachers. How many of them are there? 275. Could they all come out as principals? Sure. Could they all come out as teachers? Sure. They didn't specify any of that, right? That's why I can lump them together, because it doesn't matter. It just can't be students. So it's leftovers. The next one says there needs to be at most 2 principals. So at most means 2 or what? Less. If I go to a store and I need at most $2. I need $2 or less dollars, correct? Now you have to watch yourself with the at most cases, because you have to remember that that could also be 0 principals as well. I can have at most 2, so I could have 2 principals, or I could have 1 principal, or I could actually have no principals, because I need to have at most 2. So I could actually have none. So I have to give myself cases. So I have 2 principals, or 1 principal, or no principal. Cool. So this is a committee of 2, a committee of 1, and we actually have no people on that committee. So we're good. Does that make sense? No. How many do we need? 12 on every committee. Every case needs 12 people, yes? The third case is so crappy it actually has no people on it. It's just an empty person case, okay? So we have 2 principals and 10 others, or 10 not principals, technically, right? Or we could say 10 students, or I don't remember what we have. Students or teachers, right? I'm just going to say not principals. 1 principal and 11 not principals. Or 0 principals and 12 not principals. So I always show my cases above because the people who write the cases out actually will do better on these questions. Right? Because you have numbers in front of you, now you just fill them in. So principals, how many principals are there? 25, and I can choose 2. And means I do what? Multiply. And add don't go together, right? And add do not go together, too similar. And multiply. And then not principals would be 8,250. 8,250 C10. Plus 25 C1. We start all over again with all of our numbers. And 8,250 C11. Or do I need 25 C0? Do I actually have to draw this one? No. If there's 0, I don't even have to include it. Could I go 25 C0 times? Absolutely I could. I do not need it because 25 C0 is 1. It's not going to change anything. So I could just end with 8,250 C12. Okay. 15. Jim decides to line up some cars in his dealership. He's lining them up, which means he's giving them what? Starts with an O, rhymes with order. He's giving them order. So if he's lining people up for a picture, he's putting posters on a wall, he's lining up cars. The word arrangement, lining up, is order, correct? So he's giving them order. If you give order, you can immediately go to blanks, because blanks makes you actually visualize seeing the order, right? If it's a combination, do not do blanks. Blanks mean you're giving it an order, correct? So I get people who are like, well, I know it's a combination, and then they start writing blanks. I'm like, if you know it's a combination, you cannot write blanks. Blanks mean order. Okay? Yeah. Yeah. So here we have, he has 12 cars in total. 6 black, 3 gray, 3 blue. Determine how many ways he can arrange the cars if there are different models. So, the 3 gray. Can you tell the difference between them? Yes. It's like one's a Mazda, one's a Ford Focus, and the other one is a smart car. They're all in the exact same gray. You can tell them apart. Yes? So we would just do 12 factorial, and you'd be done for this one. They're all different. What if I caveat it? What if I say it has to start with a black and end in a gray? So if they're different models, it doesn't matter that they're the same color, it just matters that we can only put colors in spots. We don't divide by factorials, right? For this one, if they're the same model, that is a fancy way of saying identical. That means you actually have like B, 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 B for black, G, G, G for gray, and I'll use L for blue. Like you can't tell those apart, right? When they're identical, it's like having the word bagloo. Bagloo. There's not even blue. Bagloo. You have to arrange. Okay. So, coming back to this one, they all look different. So this one, you would have B1, B2, B3, B4, B5, B6. Can I tell the difference of these? So I'm giving them subscripts. Yep. And then I have G1, G2, G3, L1, L2, L3. So these ones, when they're different models, same color, you can totally tell them apart. Yes? They just happen to be the same color. Cool. These ones you have bleu. You have a lot of repetition going on. So you have to do the factorials in the denominator. Do you see the difference in different models, same model? That's how you could represent them with letters. So I have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know it can start with a black. How many black are there? 6. And then I park a car. Leave myself a black car there. Parked one. You're welcome. And then I have to go to the end, and I have to park a what? How many are there? 3. Zoom. Parked a car. How many cars are parked? 2. Mrs. Lepp in high school was a dummy. And I thought, wow, there's 9 cars parked. If you're that person, don't feel like you're alone. That was me. I'm like 6 and 3, that's 9. No, if that was 6 parked here, then you'd have to imagine like 6 stacked cars. Like if you have 6 cars parked in that spot, you have 6 cars vertically stacked. Does anyone park cars like that on top of each other? Like that'd be impressive. Just no. And then we'd have 3 here. Right? I didn't understand that you left 1 car behind. I was like, oh, 9 are parked. No, 9 aren't parked. Remember? This is 1 car parked. Say I park B1 here and I park G1 here. Right? There is 1 of each parked. Yes? So that can directing traffic. So, how many cars are left? Yes. So we have 10 left here, then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. And you'll often represent this as 6 times 3, which is 18, times 10 factorial. Right? That might be how the answer is written. Yeah? Do you see the difference between same model? They have the same colors, but they look different. Yes? B1, B2, B3, B4. So that's different model. Same model, they all look the same. So instead of 12 factorial, the answer to this question would be 12 factorial over what? 6 factorial, 3 factorial, 3 factorial. So whenever I have identical objects, I immediately write them out as letters because I find that easier. And then it reminds me to divide by the factorials. Okay, last question, then you're going to have questions to work on. Okay, so here we have a menu consists of 4 appetizers, 5 main courses, 6 desserts. I'm picking appetizers from appetizers, main course from main course, dessert from dessert, forwards from forwards, defense from defense, drivers from drivers, irons from irons, principals from principals, students from students, teachers from teachers, boys from boys, girls from girls, clubs from clubs, spades from spades. Is it a perm or a com? Com. When you pick the object from the object, it is a combination. Yes? Appetizers from appetizers. So I get 4 what? C1, and then I get 5. C1, and then I get 6. C1, and then I add them or multiply, because there I'll always have the answer to both those options. Why are we multiplying? Because it's and. I need an appetizer and a main course and a dessert. If I add, I could have an appetizer, I could have a dessert, or a main course, right? But I want them all. So I have to multiply. You guys, these are the easiest to make multiple choice answers for. Do you want to know why? I do all C's with multiplication dots, which is correct. I do all C's with addition, which is wrong, but you didn't remember if it was added. And then what do? Instead of C's, I do P's. I do P's with multiplication, P's with addition. I have all 4 options if you oopsieing. Well, 1 right and 3 oopsies. Yes? So if you don't know what's a permutation, the answer will be there. If you don't know to multiply, addition will be there. So you need to know your stuff, right? So we multiply because it's and add don't go together. Multiply because I need this and this and this. It's a C because I'm going appetizers from appetizers, main course from main course, dessert from dessert. We agree? All right, what about this one? 2 appetizers, 1 main course, 2 desserts. 4C2 times 5C1 times 6C2. Guys, when we used to make outfits, I said you get away with fundamental counting principle, but why would you? If I have like 8 pairs of pants, I need to choose 1 pair of pants. I have 7 shirts, I need to choose 1. I have 2 shoes, and I need to choose 1. I'm going pants from pants, shirts from shirts, shoes from shoes. What should I just use? Every time. C, combination. You choose the same object from the same object, right? So what do we get here? This one and this one. And what? You guys all started at the different spots in the number. I was like, okay.